Okay, for this chapter 3, it is basically on the block diagram. We have covered on the transfer function previously, and today we will continue with the block diagram reduction technique. Okay, this is what we have learned previously. Alright, let's continue on this one. Okay, for example, we have one example for this one here. Okay, we have a spring and a mass. Okay, this K is the spring and M is the mass. Okay, so the first question is to obtain the closed loop transfer function, okay, from this system that we have, one spring and mass, by using the mathematical modeling. Okay, to get the transfer function, we have three methods. The first one is the analytical method. For the mathematical modeling, we need to derive on the equations for this system. We have spring and the mass. And then the second method is by using the block diagram reduction. We want to get the transfer function, ratio of the output to the input. Okay, and the third method is the graphical method also, but by using the signal flow graph. Okay, for this question, only comparing in between the mathematical modeling with the block diagram reduction. Okay, so for this one, this spring we need to know on the K value, and for the mass it is given on the M value. Alright, for the first one, let's do on the mathematical modeling equation. Okay, this is the system that we have, mass spring system. Okay, so from here we know that our input is the XIT, our output is X out T. Okay, and then we have a summing point for this system, summing point, because we have the displacement of Xi minus X naught. Okay, and then we have the forward path, K multiply with the M, and then we have for this mathematical modeling, we need to know, we will use on the Newton's second law for the summations of F equals to MA, and then we know that A is equivalent to d square x naught over dt square, second derivative. And for the spring, we have spring for this system, Ft equivalent to k x t. Okay, so now we have xi minus x naught for here, so we need to substitute the k xi t minus x naught t. Right, so now we need to compare in between f equals to ma. So this f we will substitute into the f here, and this ma we substitute with this second derivative. Okay, so our m here is 4, so we can put straight away 4 d square x naught t, this is x naught t over dt square equivalent to k. K is 2, so you can straight away put 2 xi t minus x naught t. Okay, so our purpose is to get the the transfer function, which is the transfer function equivalent to x naught over xi. So we must get x naught over xi in terms of s or in terms of t domain. Okay, so now we have this one, so we can take the x naught to the one side and x out to the other side. Okay, 4 d square x naught t over dt square plus 2x0 t equivalent to 2xi t. Okay, so for here we can divide everything by 2, so this one will become 2, this is become 1. So we want to make the equation simpler, and now we can take Laplace for both sides. Okay, Laplace, so we can have we must write the everything, 2d square x 2t over d2 square plus x0 t Laplace this side xi t. Okay, so next one, let me write down here. Okay, we want to make it obtain the Laplace for both sides, so m s square x naught s equal plus k m will be 2. So here we just straight away substitute from this one. We will have 2 s square x s plus this is x naught. Okay, x naught s equivalent to xi s. Okay, so now we can have the equation x naught 2s2 plus 1 equals to xi s. So next, okay, let's tambung kat bawah. So we can have the x naught s over xi s 1 over 2s square plus 1. So this is the transfer functions of this system. Okay, alright, question number 2 is draw the block diagram. So this is the block diagram actually. Okay, for the system we have one input, so this is, you can also write as xis x naught s. Okay, so this one is k, you can put as 2, k is 2, right? K is 2, m is 4. Okay, so you can straight away put k is 2, m is 4 for the second derivative. D square equivalent to 2s2. Okay, so you can have this one for straight away 1 over 4s2. Okay, so this is closed loop unity feedback, because our feedback here is 1, so we don't have the feedback. Okay, so from this block diagram we can do the reduction. Okay, the first thing is we can cascade this one. Okay, so we need to redraw. Okay, we have the xi. Okay, the summing point, you go to k. When we have this cascade, meaning that k multiply with 1 over md. Okay, or 1 over ms square. You can substitute 1 over 4s square. This is s2. Okay, so 2 over 4s square will become this block. This is the output, x out, and then we have the feedback here, negative feedback. Okay, so formula for negative feedback, transfer function closed loop, it will become x out over xi equivalent to gs over 1 plus gs hs. Okay, so now why it is plus? Because we have negative feedback. So substitute all in here, it will become, okay, saya tulis sini lah. Okay, 2 over 4s square over 1 plus 2 over 4s square. Okay, and then what you can do, 4s square over 4s square, 4s square plus 2 over 4s square. Okay, and equivalent to 2 over 4s square over 4s square plus 2 over 4s square. So boleh potong this one and then you will get 2 over 4s square plus 2. So this one boleh potong 1, 2 dengan 1. So you will get 1 over 2s square plus 1. So this is the transfer function of the system. Okay, so let's compare. This is the final transfer function and this one yang kita kira tadi. Okay, sama tak? This one. Okay, so meaning that when we use 2 or 3 methods, we can get the same transfer function to represent the system. Okay, so now I would like to explain about this block diagram reduction techniques. We have few methods or few steps. Ada beberapa cara that we can apply for the block diagram reduction. Okay, and this table is very important. The first one is under combining block diagram. So let's say if we have two block like this, okay, G1 and G2, we can cascade darabkan dia. Okay, so this is 1 and this is 2. Saya sama je, you boleh tulis macam ni ataupun you tulis macam ni. It's like 4 darab 2 equals to 8 ataupun 2 darab 4 equals to 8 also. Okay, okay, this is the first cara. Ada beberapa cara, so kita boleh pakai mana-mana. And remember, all this cara you need to ingat, ataupun kalau tanya saya kena hafal, yes. Kita takkan bagi this table. Okay, yang kedua adalah moving the summing point behind a block. So this one we call as the summing point. Okay, kalau kita nak pindahkan this summing point to this point, kita kena tambah like di satu block ini yang sama macam yang kita lompat tu. Okay. Okay, and then remember, tambah ini akan represent sama dekat sini. And then kalau kita nak moving a peak of point, okay, this one kita panggil as peak of point sebab dia tak ada bulat. Kalau dia ada bulat like tadi, this one, ini kita panggil, call this as summing point. This is a peak of point ataupun a node. So now kita nak pindahkan ke depan. Okay, so we want to pindah ke depan, kita kena darab dengan G. So kita kena adakan this G. Okay, the third one is moving the peak of point behind a block. Daripada kat sini we want to put over here, so dia akan jadi like this one, bahagi dengan this 1 over G. Kalau moving the summing point, sama juga, we want to bahagi the summing point. Kalau summing point pergi ke belakang, kita kena bahagi. Kalau yang tadi summing point pergi ke depan, dia kena ada G je. Okay, dah bahagi G ataupun G saja. And then this is for feedback. Ini yang paling banyak kita pakai adalah feedback loop. Okay, yang this one kena tengok on symbol here. Another one, number 7, is cascade. If we have two block, X1 dia pergi ke G and pergi ke let's say this one is G and then this is X2, another one is G2. Okay, this is dua-dua adalah forward. Okay, dua-dua ke depan. Okay, if this case, dia akan jadi block dia G1 plus G2. Okay, this is parallel. Okay, kalau parallel. Okay, this is summary block table yang sama macam tadi, cuma ini adalah table lukis lain. Cuma this is the same things. We have 6 together, and another one yang lagi satu you boleh tambah is this one lah, yang parallel. So this is cara-cara dia. Okay, we have one example here. Okay, for this example, the first step is what you can do adalah reduce this one. Okay, how to reduce? Yang ini guna feedback. Okay, once dah reduce yang itu, what you can do next adalah yang warna biru pula, you do this one. Okay, this number 2. Okay.
Ada elok lah.
Alright, after the first step, okay, after the first step, okay, the red box, okay, we do settlekan yang feedback G2 dengan H2, and then step yang kedua cascadekan dengan G1, okay, and then step yang ketiga baru solve with the H1 ni. So ini step yang ketiga. Step yang keempat parallelkan with this G3, step yang keempat. Okay, so kita tengok. Right, so this is the first step. Yang ini, okay, do the feedback, gunalah formula yang G over 1 plus GH ataupun minus. Okay, and then kena lukis semula. Bila dah settle yang itu, lukis semula and then cascade these two. Bila cascade, dia akan jadi G1 kat sini. Okay, like this one here. Okay, cascade kan, and then baru boleh selesaikan with this H1 yang bawah dia. Okay, bila dah selesaikan with this H1, dia akan jadi satu blok je lah. Okay, and then you can solve antara dengan G3 sini. So yang ini nanti akan masuk kat sini. So it will become like this one. And then our main target is not Y over R. Okay, so final transfer function kita as this one lah. Okay, so transfer function is equivalent to Y over R equals to this one semua. Okay, right, we have one more example. Okay, reduce the transfer function for this one. Ini panjang sikit, ada banyak block, tapi we need to do one by one. Okay, the first one is kena tarik this peak of point, kena letak dekat sini, pindahkan kat situ. So yang ini nanti dia akan jadi H over G4, H2 over G4. Okay, sebab kalau peak of point kita tarik, dia akan jadi over 1 over. Okay, so and then lepas tu baru kita boleh selesaikan untuk bila dah tarik, kita boleh buat yang ni dalam ni dulu. Okay, cascade G3, G4 dengan H1. After that baru kita boleh selesaikan dengan yang atas. Okay, this one lah. Bila kita dah pindahkan, dia akan jadi like this one, and then we solve for yang ini dulu. Okay, cascade and also dengan feedback. So it will become like this one. After that baru kita boleh selesaikan for this part yang ini. Okay, this one is cascade and then feedback kan dengan yang ini. So yang ini memang kena rajin tulis. Okay, eliminating on the feedback loop. Okay, and be careful on the symbol of the feedback. Macam this one, this is also feedback, so with negative. Okay, and dia akan dapat like this one. This is the final one. And then this one kita cascade and feedback with this H3, negative feedback. Okay, so this one will be the final transfer function equivalent to YS over RS, sama dengan semua yang ini. So this is the block diagram reduction in order to get the mathematical modeling transfer function for the system. Okay, alright. So setakat ini, this one is very important, yang table ni, this one ataupun summary samalah dengan yang this table. So this is very important. Antara semua ni yang kerap kita pakai adalah yang ini combining cascade, yang ini moving ni ada tapi tak banyak sangat lah. Yang confirm memang akan ada dekat dalam block diagram reduction is yang ini dan juga yang ini. Okay, tiga ni memang confirm, memang ada. Okay, yang ini cascade, simplify, ataupun lagi satu adalah yang parallel ni, parallel this one. Okay, alright. Kita tengok sikit on the signal flow graph. For the signal flow graph, this is actually macam ni lah. So this is input, so this is the output. So satu kotak block diagram tu, the G tu, we can represent in terms of like this. Sekejap saya lukis. Okay, we have the input, this is the output, this is the output. Kalau tak, kita akan ada satu kotak kat sini. So this kotak we represent as the anak panah. So this one akan jadi GS. So sini akan jadi GS. Okay, So ini kita akan masuk next class. I will explain further about this block diagram signal flow graph in our next class. And kita akan dapat juga on the signal flow graph ni untuk dapatkan dia punya mathematical modeling or transfer function. Okay. Alright, so that's all untuk this class.